My name is Thomas James, and this is Wheelie Drive. Wheelie Drive is an autonomous robot that will take your wheelie bin to the curbside for you. But let's start at the beginning. Imagine you're in your twilight years, or have a disability. You can no longer walk unaided. How do you get your wheelie bins to the curbside? You can't take your walking aid and the bin at the same time. Imagine it is the end of the summer holidays. You are leaving your batch, but your wheelie bin is half full and the collection day is a few days away. What do? You can't leave your wheelie bin at the roadside for months on end. You don't want to leave rubbish in your bin for months on end. What do? These aren't uncommon concerns. My elderly neighbour was told by her doctor that she is not allowed to take her bins out because there is too much of a risk of her falling. With these issues in mind, I set out to create a robot that would take your wheelie bin to its collection point for you. The first step was to find a means of lifting the front of the bin so that it can be moved. I initially investigated lifting the bin. However, the cost of incorporating a motor with sufficient power made the idea infeasible. I then investigated mounting a device under the bin to lift the front. However, advice I got from potential customers suggested that they did not like this idea due to the fact that they were worried that during the collection process it would get damaged or stolen. I was left with the option of designing a device that would mimic the way in which a human pulls back the front of the bin. This, however, became very complicated very quickly, as the wheels of the bin will get dragged if being turned by wheels that are mounted square to them. The only solution I initially saw was having swiveling driving wheels, similar to a car. Controlling the swivel was going to be very complicated, akin to trying to back a trailer. The breakthrough came when I realized that if the driving wheels of the device are mounted outside of the bin's driving wheels and in line with the axle, the center of rotation of the bin's wheels will be the same as the robot's driving wheels, enabling the two sets of wheels to turn together. This led to the development of my current design. Turning the design into reality required the creation of three key systems: the connection and pullback system, the drive system, and the navigation system. To avoid mounting anything on the bin, I designed a connection system that, like humans, makes use of the wheelie bin's handle. A linear actuator is used to extend the arm under the bin's handle and to pull the bin back. The arm is overextended so that it can fit under the bin's handle. As the arm is raised, the robot is moved forward at the same rate, so that the arm continues to be in position to fit between the bin and its handle. The movement of the robot is controlled by an Arduino using proximity information from an ultrasonic sensor, and the arm angle information from switches which are activated when the arm is fully extended or contracted. The robot's driving wheels are chain driven. This enables the motors to be mounted behind the wheelie bin, minimizing the width of the robot. The robot navigates using a predetermined path, pre-programmed with distance and direction information. In the future, I'd like to reincorporate GPS navigation into the robot, as to date I haven't been able to get location data precise enough from GPS. I'd also like to make the robot smaller, as well as incorporating an obstacle avoidance system so that the robot can make its way around objects in its path.